Good morning. As promised, we are going to discuss the next two transformations here in video form instead of in class. So the first of the two are dilations, and we can call dilations either a stretch or a shrink. So we're going to make this figure triangle ABC bigger and smaller. The first thing we'll do is stretch it. So we're going to dilate it by a scale factor of 2. N is a scale factor. And if you notice, I moved the triangle to the left a little bit from our original position, so let's get the new coordinates here. C is 1, 0. B is 4, 4. And A is 0, 6. So what it means to dilate by a scale factor of 2 is just to take all the x's and all the y's and multiply them by 2. So if we did that, we'd get 0, 12, 8, 8, and 2, 0. So these coordinates in blue will be the coordinates for our new triangle after dilating. So we can draw those. There's C prime. There's B prime. And there's C prime. I'm sorry, A prime. And as you can see, when we dilated by a value greater than 1, we made the triangle bigger. In fact, it's twice as big. So when we dilate by a scale factor of 2, we've just stretched this triangle and we've made it twice as big. We can do the same thing with a shrink. A shrink is going to be a scale factor greater than 0 but less than 1, so it's going to be a fraction. And you might already guess that when we shrink a figure, we're going to make it smaller. So let me just get rid of the stretch. So just like we did with the scale factor of 2, we're going to multiply the x's of every coordinate and the y of every coordinate by 1/2. So this becomes 0, 3, 2, 2, and 1/2, 0. We can graph 1/2, 0, just got to estimate a little bit. So 1/2, 0 is going to be somewhere there. There's C prime. Then we've got 2, 2. There's B prime. And 0, 3 gives us A prime. And we have our new triangle that we shrunk by a scale factor of 1/2. So this triangle is half the size of the original. Our last type of transformation is rotation, and we're going to rotate by 3 different degree measures here. And we're going to rotate around the origin. So this point here, 0, 0, is our center of rotation. I'm going to put a red mark on the left side of my coordinate plane because I'm going to refer to the left side of your paper. And we're going to rotate counterclockwise around the origin. So when I rotate this triangle by 90 degrees, all you need to do is take your paper and turn it to the left so that the left side is now the bottom of the paper. So you can see the red that I made the left side is now the bottom. Now we're going to write these coordinates for A, B, and C as if we're looking at a regular coordinate plane. So A is -6, 4. B is -4, 8. And C is 0, 6. These are actually the coordinates for A prime, B prime, and C prime. So if we rotate our paper back to the original position, we can graph these new coordinates. And we have our rotated triangle. So we can do the same thing for any number of degrees. We can rotate 180 degrees by turning our paper twice. So again, the red side is my left side of the paper. I'm going to turn it once so that the left side is now the bottom, and I'll turn it again so that the left side is now on the right, as you can see. And we can copy down the coordinates, flip our paper back to the original position, and graph the new figure. So A is -4, -6. We'll call it A double prime. B double prime is -8, -4. And C double prime is -5, 0. I think I counted wrong up here in the original. That should be 0, 5. I apologize for that. So then we can rotate our paper back to the original. And we can graph these new points. And there we have a triangle rotated 180 degrees. So I want you to try on your own 270. I'll give you a hint. You just turn your paper 3 times. So the left side I have here, drawn on red, ends up being the top of your page. So copy the coordinates, graph the triangle, and we can check that in class.